This is the second video in a series of videos on introduction to logs. And this one picks up where the last one ended, so let's go ahead and move on. And the first thing we want to do is we want to try to do logs without a calculator. And the easiest way probably to see this is just see some examples. So we know that 3 to the 4th is 81. If 3 to the 4th is 81, then we know that, well, I will tell you that the third log of 81 is going to be 4. What you do here is you simply do this. If you want to figure out what the 3 to the 4th is equal to 81, if you want to find out what the third log of 81 is, you simply answer this question. 3 to what power is 81? And 3 to the 4th is 81, so the third log of 81 is 4. Let's do some more. 5 squared of 25, so the fifth log of 25 is 2. 2 to the 6th is 64, so the second log of 64 is 6. 7 to the 3rd is 343, so therefore we say that the 7th log of 343 is going to be 3. 9 to the 3rd is 729, so the 9th log of 729. Again, what are we answering here? Think about what we're doing here. If we take the log 9 of 729, we're trying to find 9 to what power is 729. And it turns out it's 9 times 9 is 81 times 9 is 729, so it's 3. And that's how you do logs without a calculator. It gives us a sense of what they are, what logs are. And here's the definition of a log. We say that if y is equal to b to the x, see this is an exponential function where b and y are positive numbers, then the bth log of y is equal to x. So a log is simply the opposite of an exponential function. Now this formula I've always found a little hard to memorize, so what I do is I pick one log that's pretty easy, and it doesn't necessarily matter which one you pick. The one that I picked way back when I first learned this was 3 to the 4th is 81, because 3 times 3 times 3 times 3 is 81. Because 3 to the 4th is 81, we also know that the third log of 81 is equal to 4. And what I would do is I would memorize this right here, or one like it. Doesn't really matter which one. And anytime you get stuck or feel like you're stuck with logs, you can refer back to this. So a log is simply the opposite of a particular exponential function. Here, why don't you try some here? I'll give you the exponentials and you give me the logs. So the 5 to the 3rd is 125, so you tell me what the fifth log of 125 is. 2 to the 5th is 32, so find the second log of 32. 10 to the 7th is 10 million, so you tell me what the 10th log of 10 million is. And again, what I'm going to do is I'm going to ask you to pause the video for a second and work these problems out. Let's go ahead and check your answers here. So if 5 to the 3rd is 125, we say that the fifth log of 125 is 3. And let's think about why that is for a second, right? Let's do it this way. If we memorize that 3 to the 4th is 81 and that the third log of 81 is equal to 4, then it's just a matter of seeing where the numbers go. Here we have 5 to the 3 is equal to 125. And let's notice the placement here. Here, the base of the exponent is 3, so the base of the log is 3. So that's log base 5, because it's 5 to a power. The 81, which is the result of the exponential function, is the argument of the log now. So since we ended up resulting in 125, now that's going to be the result. That's going to be the input this time, or the argument. So we have the fifth log of 125. And what's the answer going to be? The answer is going to be, the power is now going to be in the answer, so it's equal to 3. And that's how you do it. If you notice, if you memorize this or something like it, you'll always be able to solve these problems. What's the next one? 2 to the 5th is 32, so the second log of 32 is going to be 5. And 10 to the 7th is 10 million. Let's try that one again. We have 10 to the 7th is 10 million. Again, I'm going to memorize this one. 3 to the 4th is 81. So the third log of 81 is equal to 4. Let's see. Here you have the base of the exponent becomes the base of the log, so that's log base 10. The result of the exponential function becomes the argument of the log, so that's log base 10 of 10 million is equal to, the power now becomes the answer, 7. And that's how you do logs. Now why don't you try these two without any prompting? Now in this case, you do the same problem except for you're not given the argument, so let me show you an easy way of doing this one. So here we have log base 2 of 32 is equal to blank. This is what I do this. Let's look at the base here. The base is 2. So I got 2 and I put a big question mark here is equal to 32. And then I simply ask myself, I go self, 2 to what power is 32? The 2's I don't memorize, but I can do them on my fingers. So 2 times 2 is 4, 8, 16, 32. So it's 2 to the 5th. And since 2 to the 5th is 32, that means that the second log of 32 is 5. This is called the question mark in the circle method. Let's do the next problem. Here we have log 10, log base 10 of 1,000 is equal to blank. So we do is we go 10 and we go question mark is equal to 1,000. And you go 10 to what power is 1,000? Well, 10 times 10 is 100, times 10 is 1,000. So 10 to the 3rd is 1,000, which means the 10th log of 1,000 is equal to 3. And that gives you a pretty good idea of how to do logs to start with. And what we're going to do is we're going to end this video here and you can watch the next video, which is part 3.